Let's begin our pergola at Portal Frame Generator. Portal Frame Generator is a wizard for Cype 3D. It's going to help us start our geometry by generating a monopitch rigid portal frame. It is going to have two spans in a 6.5 meter distance between frames. Also at Portal Frame Generator, we're going to design and obtain the ULS check report of the roof partlines. At the end, we'll export to Cype 3D the geometry and the wind and snow load generated. If we take a look at Cype's menu, we find right away Portal Frame Generator. Here in the program's first interface, we find the New File option. We're going to name our project Pergola and click Accept. This software will ask if we want to enter a new frame. Let's answer yes. It's going to be monopitched in our case. And it's going to be a rigid frame of 4.5 meters to the left, 4 to the right, and 6 at the bottom. If we click at the configuration menu and go to the code selection, we'll be able to select the code for the design of the partlines. For our example, we're going to select the Euro codes, but the software is adapted to many other codes too. Also, at configuration menu, we can find the unit settings. We're going to select the International System of Units. Now let's set the general data. In Project, General Data, we're going to define the number of spans, which is going to be 2, and a distance between frames of 6.5. Since it's a pergola, it's only going to have roof cladding, but the software allows for lateral wall cladding as well. Let's select the roof cladding and add external panel weight is going to be 0.10 kilonewtons per square meter. No additional live load for now and no lateral wall cladding. We're now going to select the parameters for the wind and snow load generation. For the wind loads, let's select the Euro code and leave all the parameters as they come by default in this case. For the snow load generation, we're also going to select again the Euro code. And here we can find a help menu to select the region. We're going to select the Iberian Peninsula, Zone 1, Normal, and we're going to set a topographic height of 600 meters. Now that the parameters are set, let's insert the roof partlines. For that, we're going to click again in General Data and edit Lateral and Roof Partlines. Partlines on Roof. And we access the menu of the roof partlines. In the Analysis Data, we're going to find the deflection limit, the number of spans, and the type of attachment. If you have any doubt, you can consult the help, and these parameters will provide further information on these parameters. If you do a right click, you exit the help, and let's set a deflection limit of length divided by 250, one span, and rigid fixing. There's 3 design options for the purlins. As there are 3 design parameters: type of section, separation, and type of steel. If we define 2 of the parameters, the software will design the third. For example, here by clicking in section type, we can choose from various types of sections. We can either create our own series of sections or select from a library by clicking on the Edit the list of elements and then Import of predefined section series. Any IPE series will be okay for our example. As we're going to start the design from an IPE 80 section. We're going to set a separation of 1.3 meters. And a steel type is going to be FE 430. With these 2 parameters, we're going to ask the software to design the section. Here is a list of the sections from the series, and software lets us know the demand capacity ratio for each section series. We're going to double click on IPE 200 and click Accept. If we accept again, the software will let us access the ULS check report of the roof purlins. This is a full code check report of the purlins, completely detailed. And maybe now could be a good time to export it to PDF format. If we exit the report, we can now see our portal frame with the roof purlins inserted.